Hey,
Hello.
how are you? Oh, I like that. Is it like mochi?
No, Mochi is supposed to be a lovebird. I just drew a circle with a
Ah,
face on it, and four legs that are awfully like sticks.
oh, okay. Well, I wasn't sure if you were still working on it. All right. Oh, very good. So, how was your week?
My week was great. I went to Universal and I got an owl.
Nice, an owl like my owl.
No, not.
Not Hedwig.
Yeah, it's Hedwig, but wow. I don't have.
Does it move? Yeah.
Yeah, it moves, but it's not that Hedwig. First, the name, it's called Baby Hedwig. You can give it a name. It doesn't know its gender. It knows its name. It also kind of just listens to the person that plays with it much longer.
All right.
His name is Hedwig. I gave him a gender and a name. He doesn't know his gender. However, they said you can give your owl a name, even though they don't know a gender.
Well, there are some names that are gender neutral, meaning, so for example, I had a brother named Shannon, and Shannon can be a girl name or a boy name. It's not really, we call it gender neutral. There's also a name like Kelly. Kelly can be a boy name or a girl name. So yeah, there's different names you can do that are like Grayson is another one. That doesn't work in Paraguay though, Ivanka, because all the names that are girl names here in Paraguay, they always end in like Maria. Like they can't even do that with my name. So my name and Capucine, my 4-year-old, they both have closed sounds. So it's Candace and it's Capucine. So they always do Capucina or Candace. Like it has to, a girl's name has to end in like an or an Penelope. So they can't just, they don't call me Candace. They can't. They don't, it's very hard for them to do a closed sound at the end. So they always say either Candace, which is awful, or Candy. 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 Yeah, I don't like that name, but it is what it is. But your name ends with an A sound, so yours would be fine. They would likely be okay saying your name, Ivanka. How did you choose your name? Is that, how long have you had your name? It's a pretty name. I like Ivanka.
I had my name for 8 years. Never changed.
Okay. Do you have a Chinese name and an English name, or do you have just one name?
I have an English name and 2 Chinese names. One Chinese name is supposed to be the name your parents call you, and the other name usually three words or 字.
Okay.
Kind of. It's the name that will usually be called in the school. Whereas in your house, they usually call you the other name, the other Chinese name.
Okay. So I only have 3 names. It's Candace LaVon Malfoy. But my kids, they're French. And in French culture, there are many names. You have your given name, like you're talking about, like the game that you're called, like Ivanka. But then you have your middle names are your mom's name, your grandma's name, and then your godmother, and then your last name. So all my kids have lots of names. So it's Capucine, Sana, Levon, Catalina, Fuller Malfoy. That's her whole name. I have to like think about it. And my son is Louis Michel. It's in French. Michel is Michael. Michel Arnaud Jean Fuller Malfoy. So they all have lots of names, and my maiden name is Fuller. The thing is Paraguay law is that the last name of the mom has to be on the birth certificate. But when we had Penelope in Malaysia, that's not the law. So Penelope has no Fuller. It's just Malfoy. So Penelope Florence Christelle Celeste Malfoy. So yeah, lots of names. When I worked for my other company, they had to do all of the immigration paperwork for Penelope, and they did not like me because they had to write it all in, like all of her names 20 times on the form. Would you ever want to change your name? I used to when I was a kid.
Once I wanted to change my name into Unicorn.
Don't do that. Don't do that. Yeah, I have some students who were very young when they chose their name. So I have Spider-Man, Iron Man, I have Teddy Bear.
What?
I have colors and fruits. Like I have a student named Melon. I have a student named Lemon. So it's fun, but I like that you guys can pick your names. All right, well, this is a good lesson for what's recently happened. The U.S. just sent a spaceship around the moon. So what does it take to explore space? What do you think you need to explore space?
You need this, I know, spacesuit.
Yeah, proper clothes. Why would you need that? Do you think it's hot or cold in space?
It's cold in space. You need that thing.
Yeah.
Definitely that thing. This is a human. I think.
Yeah, I need a spaceship. Good.
You also need this thing.
You have a spaceship.
Yep.
Good, very good. Okay, we're going to watch a video today. All right, so the astronauts are doing a spacewalk. Do you think it's easy to have a spacewalk? No. Then we're going to watch a video today. No, right? They have to practice a long time. They need lots of training. All right, so we're going to watch a short little video. Ready?
Isn't it cool to have a spacewalk? Recently, 3 astronauts arrived at the International Space Center. Look at the astronaut. He looks confident and relaxed. However, moving in space is nowhere near as easy as moving on the Earth, because the condition in outer space is very different from here. Here are some problems the astronauts could face. What are ways to solve them? Wearing a spacesuit can partly help with the problems. The spacesuits provide astronauts with radiation protection, temperature control, water to drink, and oxygen to breathe. Besides, astronauts also need to practice spacewalks underwater in a large swimming pool because the motion of floating in space is a lot like the motion of floating in water. How do rockets send astronauts to the International Space Station? Well, before answering this question, you need to understand some basic physics and number facts first. The word space we've been talking about is the outer space. It also means the area around us. Look, the ice skater is moving in a circular motion. How thrilling. In fact, motion can make sports exciting. Let's take a look at more sports and how motion makes them exciting.
All right, very good. Okay. It's been a while we haven't watched a video. All right, so think of this video that we just watched. The condition in space is different from the condition on Earth. So what are some examples of why it's different? What did we learn?
The temperatures are different from space. And there might be no gravity.
Yeah, there's no gravity in space. Good. All right, now, what is one way that the astronauts overcome this problem?
They wear spacesuits so that they can drink water, have air, and stuff.
Yeah. Very good, very good. And they need like special tools to be able to eat and drink. Everything floats away, so they can't drink water from a cup. They need a straw. All right. Now, moving in space is difficult but exciting. So let's think, how does motion make sports exciting for us? All right, so we have a few different vocabulary words we're going to learn today before we do our reading. So go ahead. Measure. Measure.
Measure. The fans wait for the officials to measure how far did a player move the ball. Well, we don't know.
Yeah, so they have a measuring. They usually use a stick in American football. American football is so boring. So boring. All right, so they use the chains. So they have this chain. So the thing is with an American football field, there are yard lines. So they measure it in yards. So they can tell each one, they can know how many yards. So we have like the 50-yard line, the 49-yard line. All right, so they already know some measurement. So they use the chain to go from the yard line to how far the ball went in the middle of the 2-yard lines. All right, so we have the 50-yard line and then each direction, 10, 20, 30, so 40, 50. So there, every 10 yards, there is a line. So the ball was at the 35-yard line in the beginning, and now it's at the 44-yard line. If you were one of the officials, what would be the data that you measured? How far did the ball move?
I think I would have measured this.
All right. So what? Yeah, very good. So what is this called? So we have different things of measuring. What are these two lines called? We have the length and the width, right? The length and the width. So this is, we have the yard lines here. And then we have, let's go ahead. Now, which one is longer, the length or the width?
The length is longer than the width.
Very good. So, which word would you use to describe how tall you are? You can use metric system. How would you say how tall you are? What word might you use?
Probably length. I did not say width. I think I know that you call it length, not width.
Well, width is the shorter end, so the length would be the longer end. This is a square, that doesn't work. So we would always say, like, this is the width and this is the length. All right. So we also have another word that we use called height. Height.
Yep.
So I would use height for how tall I am. How tall are you, Ivanka? Do you know? It could be in centimeters, meters, or... So, for example, I am about 164, which is like, or 5'4". All right. Go ahead. So you're 133 centimeters. So that is your height. All right. That's the word that we use for measuring how tall something is. All right. So go ahead. Please read this for me, Ivanka.
Look at the height of that player's jump. Wow. He makes touching the rim look easy. Well, no, it's not easy.
No, it doesn't look easy. He may be really tall, but it still doesn't look easy. Yeah, well, this is the one. So the player wants to touch the rim. He wants to dunk, but he doesn't know how high he has to jump. What information do you need to know to help him? What might we need to know?
I need to know, there's two ways. The first way, the common way, I think common way, is to find out how long
the height? Well,
the height.
What's this information here?
The basketball.
What's this information here?
It says it's 3.5 meters long. The second way.
3.05. 3.05. 3.5 would be 3.5 meters. So it's just over 3 meters. And we have the hundredths placed there. So then what do we need to know? Yeah, absolutely. We need to know how tall he is.
Yep.
I need to know how tall he is. All right, very good. Okay.
It just said the media
So,
link is not
what tool
connecting.
do you think you could use to measure his height?
You can use those super long rulers. I don't know what it's called.
A tape measure.
The tape measure. To measure his height. Or you can...
Yeah, very good.
Or you can let him lay down and then walk next to him. Then you just add the steps you took, the place in the middle of the steps you took, and you add them together.
Good, very, very good. So we have the height of the basket and we have the height of the boy. So then we need to find out how high
He could jump.
he casts. Yeah. So that's a tape measure. That's what we call a tape measure. All right. So now we know 1.85 meters. So do you know how high he needs to jump? I'm going to just clean this off. Do you know how high he needs to jump? So it's 3.05 meters tall, the basket. He's 1.85, which is pretty tall, actually.
You can use this to minus this.
Okay. So what is 3.05 minus 1.85?
Approximately 2 point something. Or just
Close. So it's close. So he needs to jump. So we have one. Oops, I should change the color. I can't see it. All right, so we have 1.85. All right, so I sometimes find it a little easier to see them a bit more close. All right, so I don't know why I did it that way. Sorry. 1 second. Green confused me. So we need to find the difference between 3.05 and 1.85. All right, so you have to keep in mind that we have this 8 here, right? So it can't be 2 point something because the 8 is more. So we have 0, all right? Now, what else can we do? So we have the 8. Now, we can't take 0 from 8, right? And how many 18s are in 30? It's just 1. So we know it's going to be 1. All right, so how I learned is to carry. Yes, my daughter learns a different method now. So we have 1.2 meters to touch the rim.
Oh.
Very good. All right, now let's look at speed. So go ahead, Ivanka.
Look at her strong legs. This track star can move at top speed.
Yeah, so how do you understand the word speed? What does speed mean, Ivanka?
It's how fast you move.
Yeah, it's how fast you can move. Very good. You can get from one point to the other. All right, so Charlotte wants to know her average speed in the 100 meters. Why does she need a stopwatch? What does the stopwatch measure, Ivanka?
The stopwatch measures how long it will take for her to run.
It measures the time, right? It measures time, how long. So we can measure the time it takes her to run the 100 meters.
Yep.
Very good. So that's really fast, actually. 13 seconds. I don't think I can run 100 meters in 13 seconds.
What?
All right, so okay, good. The sound. I wish they would just have an option to play it and stop it. I don't like the sound just surprising us. Because when I have lesson notes, but a lot of times the sound doesn't work in our notes, so I don't actually know a lot of the slides which have sound. All right, now this word is accelerate. Accelerate. So go ahead and read this for us, Ivanka.
Listen to the engine's roar. The cars accelerate quickly to well over 100 miles per hour.
Mm-hmm. Good. Very good. So 100 miles per hour is around, it's almost I think it's 100 km. 100 miles per hour. Is around 160. So it's really fast. 160. So all right, welcome back. So the speed of an object increases when it accelerates. It means to go faster. All right. So let's talk about that. So we're learning different ways to measure. So both miles and kilometers are units of measurement of length. 1 mile is equal to about 1.609 kilometers. All right. So I only deal with kilometers. The metric system makes so much more sense. But we're going to learn as well the imperial system that is still used in America. So when the car accelerates to the speed of 100 miles per hour, how can you interpret it in a speedometer?
What's a speedometer?
Speedometer is this. It calculates how fast you go. Every car has one. Every motorbike has one. So it tells you how fast you're going.
Oh. Okay.
So where could we put 100 miles per hour? Here. So remember, I just told you that 100 miles per hour is about 1 kilometer is 1.6. So how could we make this? What is 100 times 1.609? Oh, we just have to move a decimal place over by the zeros. Right. So 1.609 times 100. So we have 2 zeros. This one's an easy one. So we just have to move it over 2. So it's 160 approximately. 160 and some change. All right, so that's how we can interpret that. All right, so here are some examples of how motion makes sports exciting. So go ahead, Ivanka, read the exciting sports moments for me.
Exciting sports moments. The fans wait for the officials to measure how far the player moved the ball.
Good.
Look at her strong legs. This track star can move at top speed. Well, you don't really know.
Yeah, it's just saying top speed. We have nothing to compare it to, but you're right. All right, go ahead. So look at the height.
Look at the height of that player's jump. He makes touching the rim look easy. Listen to the engine's roar, which is kind of disturbing. The cars accelerate quickly to well over 100 miles per hour.
Yes, very, very good. 100 miles per hour. All right. So how fast does the car go? And how do we know?
The car goes 100 miles per hour because...
What can we use to measure how fast it goes?
We can use a stopwatch.
Yeah. Good. Or the speedometer. All right, the speedometer in the car. It's like the speedometer. The speed meter. All right. All right. Now, we're not doing writing because this, I always do this. If you don't have a keyboard, it doesn't accurately show how fast you can write with your trackpad. So we're not going to do a word per minute test for this because it doesn't mean anything if you're writing. It takes forever to write as opposed to typing. So what kind of motion do they use? So let's look at each one. Let's look at this. Choo-choo. What kind of motion? How does a train move? Does it move in a line? Does it move fast, slow? Does it curve? Is it
fast?
spin?
It can curve.
Uh-huh.
It's fast. It can go straight and curvy.
Good. What about a merry-go-round? What kind of motion does a merry-go-round use? Does it go straight or in a circle?
It uses an engine. It goes in a circle.
Yeah, very good.
Yep.
And what about a swing? How does a swing move? How does a swing move?
A swing moves like this. However,
So it goes back and forth, right?
Yeah. However, in very dramatic cartoons, they go in a circle. Wee, and then the character.
Yeah, that's true. Like there is like this pirate ship ride. All right, very good. We're going to continue. All right, so we're going to compare how are Earth and Mars alike and different. So look at this chart. We have a lovely comparison chart that has lots of information on it. So looking at Earth and Mars, how are they alike and how are they different?
They're both rocky planets, I think.
Good. Yeah.
They have moons, but however, Mars has two very tiny moons. Wait, what's going on?
Good. Yeah, that's just the asteroid belt that separates the inner from the outer planets.
The size is different. The color is different. They both, they also have a different thing about their past. So in the past, the Earth looks like Mars. Basically, the Earth is really hot. Whereas in the past, Mars is basically kind of like Earth.
Yeah, not that long ago, only a few 100 million years, Mars used to have oceans and rivers and an atmosphere. Scientists think, and they don't know why, but Mars lost its magnetic field. And because of that, all the water that was outside disappeared, couldn't hold. And they don't know why, just lost its magnetic field. All right, very good. So we have this information. Now let's continue. So vehicles. Please read this one for us. Vehicles.
Vehicles. How it moves, number of wheels, how people guide it.
Good. All right. So thinking of this one.
Oh.
Yeah. So think about that chart as we read.
Many people in our city drives cars or ride bicycles.
Good.
Both vehicles help people get from one place to another, but they are very different. Cars have motors that help them move. Bicycles move when the rider pushes the pedals. Bicycles have 2 wheels, but cars have 4. People use
Handlebars, like the handlebars.
to guide bicycles. They use steering wheels to guide cars. Both vehicles are a good way to get around.
All right, good. So let's look at this comparison chart. Let's look at the bicycle. So let's look at that first column, how it moves. So what do you see in the article in this paragraph about the bicycle? How does a bicycle move and how does a car move? What could we add?
So, okay. So, blue
Right.
is
a little help here.
bicycle.
So how do they move?
Red.
Right? How does it move? Okay.
And red is the car. Okay.
Good. All right. Good. So cars have motors And how do bikes move? What does the rider need to do?
The bicycles move. The bicycles move, and the riders push the pedals.
Good. All right. Now, how many wheels do they have?
4.
Good. All right. So we have 2 and 4. And how do people guide them?
Oh,
Yeah, very good.
wait. Oh.
Yeah, people use handlebars. And for cars?
Cars. They use steering wheels to guide cars.
Yeah. Yeah, very good. Steering wheels. All right, so let's talk about sports. So which 2 sports would you like to compare?
Running
And think about a sport that requires speed and strength.
running and jump roping.
Okay, so where where can you do them? And what's the goal of each?
You can run in a marathon race or
Yeah.
in a park that's not too rocky. You can
But
jump
yeah,
rope.
and you can run in Rocky, but it's not fun. I'm telling you, that's not fun.
You can jump rope in a place that 100% has to be not rocky. You can do it in the park.
All right, good.
You have to win the game by running the fastest. You have to win the game by, well, there's not a game. You can win the jump rope game by jumping more times. You need shoes and leg muscles to run, and you need a rope.
Okay.
You need a rope, and you need a rope.
Okay. Yeah.
Yep, you need a rope and
Okay.
you just need a rope for jump rope.
Okay. Yeah, you need a rope that's the right length for how tall you are. Very good. All right. So we have our story. What's faster than a speeding cheetah?
A plane.
So
A plane.
yeah, a peregrine falcon. But no, cheetah is the fastest land animal. And how fast can you run a 100-meter?
Don't
race.
know.
Yeah, I actually don't know either. I have this app that I use, and it tells me. But I mean, I haven't ran in a week and a half now. It's awful. So let's look at this one. So I have my distances and goals. It doesn't have. Here we go. Here's my best efforts. So I have this app. It's like my best efforts. This is all post my surgery last year. So that's my 5K. Now the lowest it goes is the 400 meter. So I can do 400 meters in 1 minute, 27 seconds. That's 338 kilometers. I would run a 3.38 kilometer, 3 minutes and 38 seconds to run a kilometer. I can't run a kilometer that fast. I'm working on it though. That's the only one I know. So I'm pretty fast for my age group, but I'm not fast. Like I would never go to the Olympics fast. All right, now let's go ahead. Now we have the peregrine falcon. So what do you see in these pictures, Ivanka?
I see ostriches, leopards that look really like dogs, humans that look really weird, and a bird. Just a bird.
Yeah, that's
a flying.
Yeah, that's the peregrine falcon. Well, the fastest human can actually run a little faster than that. His name's Usain Bolt. So let's look at this chart. What information can we gather from this bottom chart, Ivanka?
What information do the whole
Horizontal and vertical axes tell?
How much faster than a person can an ostrich run?
Yeah. So look at this chart.
30
These are miles per hour.
miles.
Yeah.
30
Very
miles.
good. Yes. And look at that peregrine falcon. Now this is the speed when it dives for food, not when it flies regularly. All right. So the peregrine falcon used to have the top speed in the previous bar graph. But what does the bar graph show now about the peregrine falcon?
How fast it moves when it's normally flying.
Yeah, so we know that the peregrine falcon isn't as fast as the things that we've made, like a propeller plane. It's not as fast as the speed of sound. It's definitely not as fast as a jet or a rocket. All right. Now, can you look at this chart and estimate the speed of sound waves traveling through the air?
Okay, I don't really know.
Well, let's look at the chart and we can see that here. So we can draw a line. Not the best line, sorry. So we know that it's over 600 miles per hour. And we know this is 600, then 900. So it's probably close to 700 miles per hour from this chart. All right, so space speeders. What do you see in these two pictures, Ivanka?
There's the jet plane, the rocket ship, and the meteorite.
Yeah, all right. So let's talk about which one is the fastest by a lot, right?
The meteorite is the fastest.
Yeah.
If you shrink that, the jet plane is this much. The rocket ship is this much. And the meteorite would be this much.
Yeah. So it's faster because drag is a force that acts against objects when they travel through air. So we know that this doesn't have any drag. It's in space. There's no drag in space. Why we have faster things in space is we don't have any atmosphere, any air slowing things down. All right, so a beam of light could circle Earth more than 7 times in 1 second.
What?
So, yeah, well, light is the fastest thing that we know about right now. So, have you ever thought about the speed of light?
Yes, I did.
Yeah. All right. So it's 186,000 miles per second. And these are comparisons. So how long would it take to travel from Earth to the moon? So we have our rocket ship, only 9.5 hours to get to the moon. It's actually not that bad. So these are very interesting things. So even the meteoroid would take an hour and a half. All right. Now, all of these, actually, we'll take in the supersonic jet. All of these wouldn't be in space. So they would all have significant drag. All right. So based on the chart, Ivanka, which 3 objects travel fastest through space?
The rocket ship, the meteorite, and the light.
Yes, very, very good. All right. Now, here are some different things. We have the speed of sound at high and low altitudes. So it's slower at high altitudes and faster at low altitudes. Why do you think that is?
I think it's due to the height, literally.
Yeah, could be the height, and it could be the atmosphere.
Is because it can spread here, 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 here.
Yeah.
If it's on the floor, it can only spread here, 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 here. It spreads.
All right, that's a good
less.
theory. All right, good. All right, so we're going to read this selection in our next class. What's the genre of this selection? What kind of writing do you think it is?
I think it's a science.
Well, think about all of the vocabulary we learned today. What kind of vocabulary did we learn?
Math article.
Yes, good. So we learned all these different math words: height, width, length, speed, acceleration. So we learned all about measuring things. All right. So can you give me some examples of number facts? What are some number facts that we might read in this math article in our next class? Think of the distances, heights, like what might we read about?
We might read about how fast a cheetah goes.
Yeah, very good. And how would we measure that? How do you think we could measure a cheetah?
I have no idea.
All right. Well, it's actually quite difficult. So it's not like we can put a cheetah on a treadmill, right? And cheetahs run fast when they're hunting prey. So it's a little difficult to be able to standardize measuring how fast the cheetah can run. But we still have our speedometer, and we can measure how much time it takes for a cheetah to cross a certain distance. All right, so very good. Now, how are the graphs you have previewed in this article, like graphs you've seen in math or science books? Have you seen a graph like this before?
Well, I did see one in math plural. That's not, although that's not it's not a book. It's a class.
Okay. All right. And what did that chart tell you?
That chart told you how many things.
Told me
how many
Good.
things they, like, for example, these animals and the human is collecting candy. The bird collects 200 candies. The cheetah collects 70 candies. The ostrich collects 45, and the human collects 15.
Okay, so it gives you some amounts of things. All right, very good. All right, Ivanka. So this is just a review. We're going to read the article in the next class, all about the different speeds that things are. So I want you to see before our next class, if you could measure yourself, how fast you can run 100 meters. It's not very long. All right. And I'm going to do the same if I feel better. I'm still congested. So, and then we can compare how fast we both go. All right. So that should be fun for next time. All right. But have a wonderful rest of your Tuesday. I will